Okay, so now what we're going to do is kind of investigate a couple theorems. And the first one I'm going to work on is the rational zero test. And to be honest with you, it's a little outdated in the fact of like when we really need to, kind of use it. I think it is helpful to really understand when we're solving, a problem like we did in these examples, to really kind of look at these zeros and say, hey, do my zeros follow through this process? Or if something is non-factorable and you're not given, like for these examples here, we're always given a zero or a factor. So if you're not given a zero or a factor and you don't have graphing technology, then the rational zero test makes sense. However, for most parts, you're either going to be given a zero or a factor, or you're going to be given graphing technology. So I wanted to make this video just because it is something that does kind of come up, possibly at least as far as identifying the possible list of rational zeros. And that's really, about it, to really just identify those, because it used to be something that we, would be a little bit more important, but I think with the use of technology, it's not something that we need to be so concerned with. Really the main idea here is, one thing that you'll see me kind of say a lot is, it's basically the factors plus or minus of P over Q, where I kind of wrote these where basically your P is going to be your constant of your polynomial, and Q is going to be your leading coefficient. So really all you're going to do is when you're given a polynomial, make sure it's in standard form, make sure it's in descending powers. You're basically just going to take the P over the constant over the coefficient and then find all the factors. And it's really kind of easiest for me just to go through the example. So let's go ahead and do that. In this example, I have a 1 here, so that's going to be my Q. And here I have a P. My -6 is going to be P. Now, it doesn't really matter if it's positive or negative. You're just looking at the value. So let's go and list out the factors of our P. So again, these are all going to be plus or minus. So I'm going to do plus or minus on the outside. So factors of 6. So let's start with the highest. So we have 6, 3, 2, and 1. Right? Now you could write plus or minus for each one of those, but I like to just write it first. And then let's do the factors of our Q, which is basically just going to be plus or minus 1. So then to find the list of all the factors, all we're simply going to do is just go ahead and take every single factor over this, over all your possible factors of your P over the possible factors of your Q. Now this one's pretty nice because everything's over 1, but I'm still going to list them out just so you can see. So that means my possible list of possible zeros, so my possible rational zeros. So again, this doesn't tell you what the zeros are. This just tells you what is possible for your rational zeros, okay? Rational real zeros. So therefore, that's going to be plus or minus. So you take the first factor and then put it over your other one, plus or minus, 1. And again, rather than writing plus or minus for each one of these, which is kind of like a lot, I'm just going to put plus or minus on the outside. So I have 6 over 1, comma, 3 over 1, comma, 2 over 1, and 1 over 1. So this one's not that bad. You can see the list of possible rational zeros is going to be 6, 3, 2, and 1. So when you have 1 as a coefficient, it's kind of nice, right? I mean, you really didn't really have to do too much math. In this case, you can see we have a little bit bigger numbers, and we have we definitely have some coefficients that we could write out. So we have, this is our P, and then Q is going to be 2. So I'm just going to write the factors of P. All right, so that's going to be plus or minus. I'll start from the top, so 12, let's see, 6, 4, 3, and 2, and 1. So quite a bit of factors of 12, right? And then let's do the factors of Q. Okay, so the factors of Q are going to be plus or minus 2 and 1. All right, so now if I want to list at the possible rational zeros, now I'm going to basically take 12 over 2, 12 over 1, 6 over 2, 6 over 1. So it's going to be plus or minus. And again, we'll just write this as 12 over 2, comma, 12 over 1. 6 over 2, comma, 6 over 1. 4 over 2, comma, 4 over 1. 3 over 2, comma, 3 over 1. 2 over 2, comma 2 over 1, and 1 over 1. So that's the list of all the possible rational zeros. And then obviously you can see that a lot of these can be simplified, right? That can be simplified to a 6. That can be simplified to a 3. That can be simplified to a 2. And that can be simplified to a 1. So if I'm going to write these, preferably like on a multiple choice test or something, you'll see these, written in order. So we just want to make sure that we can kind of write them in descending power. So it'd be 12, 6. So that 12, that's 6. You can see here we have a 4, 3. That simplifies to a 2. 3 halves is like 1.5, so that's 3 halves. And I already have 3, 1 half, I already have 2, and then 1. Okay, so you can see a lot of these can be simplified, and that would be your list of possible rational zeros. So again, it's not telling you much. Again, this would be helpful. What's most helpful use for this is, again, if you're not given the zeros and you want to be able to identify, what the other zeros are, you can start using synthetic division with these zeros plus or minus to be able to see which one of these zeros is indeed a zero, and then you can use, further factoring it down to solve the rest of the problem. But obviously, most of the time, we're either given technology, to that we can verify, or we're just given a zero or a factor. But it is kind of helpful, and also to kind of check your work. If you were to do the zero, if you were to use the rational zero test for any of these problems that I have, you'd see all these real zeros that I provided here, 2 and 4, -4, that are part of the rational zero test. There's no rational zero there. Here, my rational zeros were 2 and 1. Those are part of the rational zero test. My zeros here was -2. -2 is a part of the rational zero test. Here, 2 is a rational zero. 2 is a rational zero. Here, my zero was -2. -2 is part of the rational zero test. So it's really just telling you it's an existence theorem. It's just saying what is possible, basically. So not true existence theorem. It's just telling you basically what is going to be possible. But it does come up, and that's why I wanted to cover it. So now we'll kind of get into another one that's very similar, which is Descartes' rule of signs.